Assalamualaikum warahmatullahi wabarakatuh. Today, we will be presenting mechanical and electrical engineering project. This is our group members, Nur Nazihah, Nurul Syazahanim, Muhammad Aiman, Nur Ain Atira, and me, Nur Anis Atira. Okay, so for introduction, Malaysia's tropical climate exposed residential buildings to high temperatures, direct solar radiation, and humid conditions, requiring constant cooling for thermal comfort. MVAC systems are heavily relied upon, but they also contribute to high electricity bills and carbon emissions. As climate change and environmental degradation worsen, the building construction industry is shifting towards sustainable and energy efficient designs. Passive cooling strategies like thermal insulation, solar shading, and natural ventilation can lower indoor temperature and reduce cooling load on air conditioning system. This project aims to equip students with technical expertise and hands-on understanding of sustainable MVAC systems for residential purpose. Okay, problem statement. Malaysia's residential heat gain and thermal design issues. Malaysia's hot and humid climate leads to excessive indoor heat gain due to an inadequate thermal design. Heavy reliance on mechanical cooling devices like air conditioners and exhaust fans, often without proper calculation and consideration for true cooling needs. Next, inefficiency in energy, oversizing or undersizing of equipment, and excessive use of electricity are common issues. Next, lack of coordination of passive design principles with mechanical system exacerbates the situation. Over-reliance on mechanical system leads to increased energy utilization and environmental issues like excessive carbon emission. Low awareness among future homeowners and professionals about sustainable MVAC design. And lastly, need for an integrated approach involving correct mechanical load estimation, energy efficient system selection, and passive design strategy integration to reduce cooling loads and promote sustainability. For the objective of this study are as follows. First, to develop efficient mechanical ventilation system for kitchen and bathroom areas with respect to required air change rates. Second, to calculate cooling loads and recommend suitable air conditioning system for selected residential locations with real market products. Third, to find and install at least two methods of passive design that reduce heat transfer by the building envelope. And lastly, to integrate and demonstrate all recommended systems in a residential building scheme to exhibit coordination of green MVAC solutions.
Hi, my name is Muhammad Aiman bin Nasruddin and my metric number was CF230269. The part that I was presenting was the finding and the calculation about our design. So the first bathroom, the air change rate was 10 SEH while the height was 3.2 meter and the volume was 10.24 meter. While the airflow rate Q equal to NV divided by 3600 was 102.4 meter cube per hour. For the second bathroom, the air change rate was 10 SEH and the height was the same as bathroom 1, which is 3.2 meter. The volume was 12.16 meter cube and the airflow rate is 121.6 meter cube per hour. The kitchen air change rate was 20 SEH, the height was 3.2 meter, the volume was 36.936 meter cube, and the airflow rate was 737.72 meter cube per hour. We moved to the upper level, which is the first floor. The air change rate was 10 SEH, the height was 3 meter, the volume was 15.6 meter cube, the airflow rate was 156 meter cube per hour. So the last area was toilet or bath. The air change rate was 10 SEH, the height was 3 meter, the volume was 12.72 meter cube, and the airflow rate was 126 meter cube per hour.
Assalamualaikum, my matrix number is CF230187 and my name is Nur Nazihah binti Jafardi. presenting about the ventilation product. For bathroom, there are total in 4 bathroom need a fan that can meet a certain minimum airflow rate. We chose Tuma Silent Series exhaust fan because it is quiet, which is low sound and has 2-speed setting and also great for home use. And also Keen and BS Boss are cheaper option because it is still cheap and powerful enough, especially for a larger bathroom. We chose Tuma Silent Series exhaust fan because it is quiet, which is low sound and has 2-speed setting and also great for home use. And also Keen and BS Boss are cheaper option because it is still cheap and powerful enough, especially for a larger bathroom. So for kitchen, the kitchen is need the most of airflow because to remove the bad smell, heat and grease from all the food and our cook. So I selected 2 options, which is Mitsubishi VG20Z40, which has strong suctions and long lasting, and also HOUM wall mounted fan, which is more cheaper and good for kitchen use with oil resistance features. And also all fans are chosen meet the need of each space, which is they are cost efficient, energy efficient, and also easy to install. So this helps to ensure a healthy air, comfort and good indoor air quality without going over budget.
Assalamualaikum, my name is Nur Shazahani Minda Abdul Mahanin, CF230080. Now, I will explain the cooling load estimation process for selected room in this project. Cooling load refers to the amount of heat energy that must be removed to maintain a comfortable indoor temperature. This step is essential to ensure that the air conditioning unit are properly sized, not too small, which will lead to inefficient cooling, and not too large, which will waste energy and increase costs. This cooling load calculation considers the room area, number of occupants, sunlight exposure, equipment usage, and air infiltration. For bedroom 1 located on the ground floor, the room size is 3.25 by 5.35 meters, giving us an area of 17.4 square meters. Using the standard of 500 BTU per square meter, the base load is 8700 BTU per hour. Next, we add the heat gain from 2 equipments, which add 1200 BTU. Since the room faces east and has medium sunlight exposure, an additional 870 BTU is considered. For equipment, we included a TV and LED light, adding up to 441 BTU. Air infiltration contribute another 435 BTU. So, the total cooling load becomes 11646 BTU per hour. Therefore, we recommend a unit with 12000 BTU per hour capacity, which is approximately 1.5 horsepower. Now, for bedroom 2 located on the second floor, the area is 3.25 by 3.75 meters, which equal 12.2 square meters, giving a base load of 6095 BTU. With 1 occupant, the value is 600 BTU. The sunlight exposure is similar, medium and east facing, adding 610 BTU. The room has a laptop and LED light, contributing 300 BTU from equipment. Air infiltration adds about 305 BTU, so the total comes to 7909 BTU per hour. For practical selection, we round this up and recommend a unit with a capacity of 8500 BTU or around 1 horsepower. Finally, for the living room on the ground floor, the dimensions are 4 meters by 5.25 meters, resulting in 21 meters square. and a base cooling load of 10500 BTU. We account for three equipments which at 1800 BTU. Due to the fast fencing orientation with high exposure and large glass area, we include 1575 BTU from sunlight. For equipment, we consider two LED lights, two laptops, and a television, totaling 941 BTU. For air infiltration, contribute 525 BTU. So, complete load is 15341 BTU per hour. To ensure comfort and efficiency, we recommend a 16000 BTU unit, equivalent to about 2 horsepower.
Okay, for passive design strategies for energy efficiency reduce energy consumption by utilizing natural sources like sunlight, wind, and thermal characteristics, particularly in hot tropical climates like Malaysia. Here we will discuss some of the primary passive methods that this building can implement. Natural ventilation is an efficient passive design method for two-story buildings utilizing the tag effect to cool interior space without mechanical system. The tag effect involves warm air moving to the second floor and venting out of opening while cooler air is pulled from the ground floor. Combining natural ventilation with other passive design strategies can achieve high energy efficiency and indoor comfort. Next, shading devices. Building shading is a passive design technique that prevents heat penetration into a building, reducing cooling system operation and maintaining interior temperature. It is crucial for two-floor buildings as the second floor faces direct sunlight. Strategies include horizontal shading device, north-south orientation, sun-moving canopies, and natural shade from greenery. The strategies maximize user comfort and promote sustainable, energy-efficient design.
So this is the final layout. We have installed the ventilation at both of the toilet and also at the kitchen. We also installed the air conditioner at the living room as per calculated. So this is the final layout for the first floor. We have installed the air ventilation system at the both of the toilet at the first floor, and also we installed an air conditioner at second bedroom. This project successfully created a cost-effective and sustainable mechanical ventilation and air conditioning system for a two-story house dwelling in a tropical region. This system was chosen based on cooling load calculations, energy economy, and roof comfort, resulting in strategies such as shading devices and insulation were incorporated to minimize heat gain and reduce mechanical systems, improving thermal comfort and promoting energy efficiency and environmental sustainability. This project highlights the importance of careful planning, calculation, and environmentally friendly decision-making in provide efficient, comfortable, and sustainable habitable space.